All right, so this is section 9, topic 2 on histograms. College students are asked how well they did on their first stats exam. Their scores are shown below. We can use a histogram to represent the data. A histogram is a bar-style data display showing the frequency of data measured over intervals. This is important. Rather than displaying each individual data value. So a histogram doesn't show necessarily that someone made an 88, but it shows that they made between, say, an 85 and a 90. So it's based on intervals rather than displaying each individual data value. Each interval width must be the same. This is important. The interval widths have to be the same. Always title the graph and label both axes. So you want to title it and label it. Choose the appropriate scale on the y-axis and the appropriate intervals on the x-axis. Histograms are often used for larger sets of data and continuous data. So data that could be 32.5 or 54.8 and so on. So an interval is a range. So describe an interval is a range of values. That's all an interval is. So if we look at the college students' exam scores to create a histogram, we need to come up with what we're going to label the x-axis by, what our intervals are going to be, and then we need an appropriate scale on the y-axis. So on the y-axis, first of all, let's come up with a title. So the title of this is going to be Stats Exam Scores. Okay, remember for a histogram, the y-axis is always the frequency or how often that particular interval happened. And then the bottom is going to be our scores. Okay, now if we look at these scores, okay, let's put them in order from least to greatest so that we can accurately compare them. So to do that, I'm going to make a list down here. I have the lowest one I see is 62, and then 66. I mark them off as I go so that I don't accidentally double count one or miss one somewhere. The next I see is 70. Then I see 72 and 73. Then I see 76 and 77. Then I see 85. There's two 85, so I want to write down 85 twice so I don't forget. And then 88. I'm going to go down here because I'm running out of room that way. Then I have 90, 92, 93. 98, 100, 100. And I always like to double check and make sure I didn't miss anything. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Great. So I'm going to label, the most I have of any number is 2 for here and here, but I'm still going to count by 2s going up here. So 2, 4, 6, 8, 10, which I technically could have counted by 1 since I'm skipping 2 spaces there. And then my scores range from 60s to 100s. So I could use my spreads here as 60 to 70. So I'm going to go every 2. So 60, 70, 80, 90, 100. And then technically that would be my last reasonable space, unless there were bonus points on the exam or whatever. So I could say 100 to 110, since 100 is that lower bound there. So as I put these frequencies, I have two, so let's count each score. So between 60 and 70, I have two scores that are between 60 and 70. So I'm going to draw a bar graph up to 2. So that would be this one. And then between 70 and 80, I have 1, 2, 3, 4, 5 scores that are between 70 and 80. So I'm going to go all the way up to 5 for that one. And then bring it down. Okay, and then between 80 and 90, that's 1, 2, 3. Between 80 and 90. Okay, and then between 90 and 100, that is 1, 2, 3, 4. Between 90 and 100. And then 100 to 110, that's 2, because I had 2 100s. So we're including that lower bound, not the upper bound. Okay, so this is my histogram. You can use it similarly to a dot plot. You can use it to tell frequency as well. So the highest frequency scores were between a 70 and an 80. So let's do another. Those same students from our first example were also asked how long in minutes it took them to complete the exam. The data is shown below. So this data is much more continuous than the first set of data was. Okay. Now this could have been continuous. The scores could have been 92.5 and so on, but this data is certainly more continuous comparatively, since all of these are decimal numbers. Okay, so we're going to construct a histogram to represent this data. So the title of this graph could be time spent on stats exam. Excuse my handwriting, trying to squeeze it in there. Okay, so I'm going to label my axes with frequency, and time. Remember, this is in minutes, so you might want to put time in minutes over here. And this time I'm just going to look at my spread up here instead of rewriting it. You certainly could rewrite it if you need to be able to see it a little more clearly. But I do see that my low value is 32, so I definitely need to include that. And then my high value, it looks like my high value is going to be upper 70s or lower 70s. I see a 71, I see a 72. So 72 is going to be my high value there. So that would fall between 70 and 80. So let's label my frequencies by 2s again. So 2, 4, 6, 8, 10. Since I don't have a frequency of really any higher than maybe 4. So then my time is going to be labeled, my lower bound is going to be 30. And my upper bound, and then I'm going to go 30 to 40, 40 to 50, 50 to 60, 60 to 70, and 70 to 80. Now I don't want to create a misconception here that you can only count by 10s on the bottom. That's just what's easier for this data set, since it is a wide spread. You can count by 2s on the bottom. You could count by whatever makes sense for your data. So for this one, between 30 and 40. So let's look carefully at this data. I see 32.3 and 35.8. So there's only 2 numbers that are between 30 and 40. So that's going to be 2 here. Okay, and then between 40 and 50, I see 1, 2, 3, 4, 5, 6 numbers that are between 40 and 50. So there are 6 numbers between 40 and 50. There's definitely a frequency that's more than 4. Sorry about that. So 6 numbers that are between 40 and 50. And then between 50 and 60, that is 1, 2 numbers that are between 50 and 60. And then between 60 and 70, that is 1, 2, 3 numbers that are between 60 and 70. So that would fall, oh, I'm sorry about this one. This one was supposed to be 2, which means this section needs to go away. This one is supposed to be 3, which would go to here. Okay, and then between 70 and 80, there's 1, 2, 3 for that one as well. So for this one, let's make some observations about the data. So the least frequent scores, the least frequent times taken were between 30 and 40 minutes and 50 and 60 minutes. But most people that took the test took between 40 and 50 minutes to take the test, to take the exam. Okay, so the try it says determine the sets of data where it would be better to use a histogram instead of a dot plot. Select all that apply. So let's think about this. So remember, histograms are best used when there's larger sets of data or continuous data. So let's go through each of these answer choices. So average daily temperatures for Albany, New York over a year. That would definitely be better for a histogram because we wouldn't want to plot 365 dots, plus those temperatures could be decimal numbers, things like that, that we wouldn't want to write out a continuous, an infinite number of numbers. So let's talk about the others. So daily weather temperatures for Albany, New York over a month. A month is a little less. We probably could plot 30 dots. I think that one's very debatable over whether you would want to use a histogram for that or not. It's still 30 data points, so I'm going to put a question mark out here. I think you could justify that one either way. So if you marked it, that one's a little tricky. The results of rolling 2 dice over and over. So rolling of dice, there's only a set amount of things that you can get from that. So I would definitely use a dot plot for that since there's only a certain amount of solutions. The height of high school football players statewide. So there's definitely a lot of football players. That's a huge data set. It's also very continuous data because you could be 4.5 feet tall. Probably not a football player if you're 4.5 feet tall, but you know what I'm saying. Finishing times at 125 randomly selected finishing times of 125 randomly selected athletes for a 100-meter race. So that one is able to be on a histogram as well. Since it is very continuous, it's 125. That's a lot of dots to have to put there. And finishing times, again, could be 2 hours and 2 minutes, or it could be any set of random data like that. So let's continue to the beat the test. Last year, the local men's basketball team had a great season. The total points scored by the team for each of the 20 games are listed below. Create a frequency table and construct a histogram of the data. Okay, so we haven't done a frequency table yet. This is where we're going to do it. And we're going to talk about how. So for this frequency table, we have 2 things going on. We have the points scored, and we have the frequency in which those point ranges were scored. So a frequency table always helps us do a histogram a little better. Now we kind of did our own version of a frequency table just by circling and underlining those numbers before, but we're actually going to list this one out. So for this data, let's make some brackets here. So I'm going to give it 9 sections. One, two, three, 4, 5, 6, 7, 8. And let's add one more out here. So I'm going to split this off into sections of 45 to 49, 50 to 54. Now remember, your sections always need to be even. So if I'm going to go 4 here, then I have to go 4 here. I can't change what I'm numbering by. So 55 to 59, 60 to 64, 65 to 69, 70 to 74, 80 to 84, and 85. Oh, I think I skipped a section, sorry. This one's going to be 75 to 79, 80 to 84, and 85 to 89. So let's take the frequency of each of these. So 45 to 49 occurs 1, 2, 3 times. 50 to 54 occurs 1, 2, 3 times. 55 to 59 occurs 1, 2, 3, 4 times. 60 to 64 occurs 1, 2, 3, 4 times. 65 to 69 occurs 1, 2, 3 times. 70 to 74 does not occur any times. 75 to 79 occurs 1, 2 times. 80 to 84 does not occur any times, and 85 to 89 occurs 1 time. So let's go to our histogram. This one is going to be a much smaller histogram. And again, my highest frequency is 4, so I could still use my frequencies on the side. Counting by 2s. Now again, I'm counting by 2s, but I'm counting 2 spaces for that, so I totally could just count by 1s, but that's too much to write. My title for both the frequency and this, or I'm just going to title my histogram as points scored. And then my bottom is going to represent the points. I know I'm writing over that writing, so it's a little difficult to see. I have my frequency table to represent this, so I technically don't have to label the bottom, but I'm going to label it just for clarity's sake here, that my intervals are 1, 2, 3, 4, 5, 6, 7, 8, 9. So I'm going to label 45, 49, well, technically it's 45, 50, 55, 60, 65, 70, 75, 80, and so on. So from 45 to 49, I have a frequency of 3. And mark that one. So this time I'm only going over 1 just because I have more intervals to fit on here now. So 50 to 54 is also 3. 55 to 59 is 4. 60 to 64 is 4. 65 to 69 is 3. 70 to 74 is 0. 75 to 79 is 2. 80 to 84 is 0. 85 to 89 is 1. So here's my tiny little frequency table. And I could say that the most frequent amount of points scored by the players were between, or by the players in the games, were between 55 and 65 points. So that's their normal amount of points. So please complete the questions below this. If you do not finish them in class, they are your homework.